purpose of this video is to demonstrate how to calculate total percent cover of invasive species on a plot given the way FIA collects its data. So I did an experiment here. I have two species, species A and species B. We're assuming that a plot is, in this example, just pretend that it's a transect and there's 100 segments in the transect. I have on this plot initially, I have 40 places where species A occurs, it gets a 1, and 60 where it gets a 0. I have on the same transect, species B occurs, and it occurs at 60 locations, and 40 where it does not occur. So we have species A is 40% cover, species B is 60% cover. And we do an experiment where we say, all right, let's randomly sort. In this example, this is just the initial setup, but let's just create a little scenario here where we say, well, we're going to sort species A, and then we're going to sort species B, such that the zeros and ones get all mixed up. In other words, they're randomly distributed. Those 40 for species A, ones get distributed randomly all along the transect. And in the same transect, species B gets randomly distributed. What that's simulating is that species A and species B just can occur anywhere in the transect given their percent covers, and it doesn't matter if species A or species B is already there. It could still occur there. So there's going to be overlap. So what I can do with this simple equation is sum up if it's a 1 for species A in this segment and a 1 for species B, then it gets a 2. Otherwise, it gets a 1. In this example, there's no species A in this segment, but there is species 1. But let's see here. Down here, we have a species 1 occurring in this segment, or species A occurring and a species B occurring. So it gets a 2. Well, with this simple equation here, I can just count up how many 2's occur in my transect. In other words, how many times does species A and species B occur? So we get with this first run of my simulation 26. Let's do some more sorting and see what happens here. So we'll sort by random. We get 22. You see? We'll do it again. 25, 23, 23, 20, 28. If I did this a bajillion times, it would average out to 24. In other words, 0.6 times 0.4. So what does this do for us? Well, we know that if this averaged out to 24, we know that species A occurs on 40% of the plot, because that's how we set it up over here. We know that the amount of species A that occurs that's not in the overlap zone and doesn't co-occur with species B is 0.4 minus 0.24, right? We also know the same thing for species B. We know that it's 60% of the plot, but 24 of the plot is overlapping with species A. We know that 0.6 minus 0.24 is the amount that of species B that is outside the overlap zone, and in other words, it doesn't occur with species A. So we can calculate the total cover as 24%, which is the overlap, 40 minus 24, which is the species A that's not in the overlap zone, 60 minus 24, which is the species B, which is not in the overlap zone, or 76%. So that's by itself an interesting finding. But then we take this equation, which comes from this Jennings et al. Paper, and we apply that equation, which is basically applying it to our example. It's just 1 minus 0.4 times 1 minus 0.6 equals 0.76, which is the exact same number that we get through our experiment, were we to have done it a bajillion times and gotten a 24 here. So what's the point? The point is, this equation can be used to estimate the total percent cover of invasive species on a plot given the way that we have overlap and we don't measure the total footprint of all invasive species, including the overlap. So we've basically just demonstrated that, oh, this equation works through a simple simulation. So we understand exactly what's going on with this equation now. So if we don't like that assumption that they just randomly occur, with each other, without impacting each other, we could say, well, gee, maybe there's a little bit of repulsion. So that 24% overlap figure, let's say that that figure is actually, you know, half of that. Let's say it's, there's really only 12% overlap because there's this 50% repulsion that occurs. Species A really doesn't want to occur with species B. So we just sort of can say, make a scenario where we say, well, let's make that 12%, and then we can adjust accordingly. So what's the point? The point is this equation can help us create like a starting point for our percent overlap, and in that way, it allows us to take the FIA invasive species data, which are difficult to calculate total percent cover on a plot, and create some scenarios of percent cover.